Welcome to the Reconfigurable Factory Testbed, or RFT. This testbed incorporates many research and education projects at the Engineering Research Center for Reconfigurable Manufacturing Systems. This is the RFT. The hardware composes two mirror image machining cells connected by a conveyor. Each cell has one FANUC robot and two Denford 3-axis milling machines. This is cell 1. The milling machines and robot are connected through DeviceNet and controlled by the ERC Modular Logic Controller, which uses modular finite state machine methodology. And this is cell 2, which is connected using Profibus and is controlled by a Siemens Soft PLC. The two cells are linked by a FlexLink conveyor. Different components on the conveyor, like proximity switches, pneumatic valves, and the conveyor drive, are connected through DeviceNet and controlled by a Rockwell PLC. In addition to the conveyor, these ramps are used to transport parts in and out of the cell. We also have a virtual factory component which was built with commercially available software and is used for simulating and testing our control and reconfiguration logic. The virtual factory contains a virtual machining, inspection, and assembly cell that are controlled by a Siemens Soft PLC. The AGV transports parts from the conveyor to our virtual factory. It is connected to the system-level controller through OPC over wireless Ethernet. All of the cell-level controllers are connected through a system-level Ethernet network to the system-level controller using OPC. The system-level controller is based on ERC Modular Logic Control. A PILS safety bus network controls the safety shutdown of the RFT. We have installed a Brooks Automation Hermos RFID system on the RFT to have process, product, and people traceability. Pallet and part tagging are implemented in both the physical testbed as well as the virtual testbed areas. The system is able to track every pallet and part from the physical testbed's loading area all the way to the virtual assembly cell. The Open Software Integration Framework provides the software architecture and methodology to connect all of the software components of the RFT, allowing for rapid prototyping, integration, and transfer of newly developed software solutions. The architecture is event-driven and data-centric. The central point of operability is the database, which stores system and application data as well as workflow rules. The Control Workflow Manager defines workflow rules to govern the uses of software modules written in various languages. The middleware is written in Java and the entire infrastructure adopts a web services approach. A computerized maintenance management system, or CMMS, is one of the software modules integrated with the RFT. It handles both unscheduled and preventative maintenance scheduling on the RFT. This is an operator view of the CMMS. We have currently modeled the RFT including cells 1 and 2 and the conveyor, which can be seen in the frame on the left-hand side. Preventative maintenance schedules have been set up for the CNC machine and the robots. This is an example of an unscheduled work request on a robot. It is indicated on the CMMS screen by the flashing red robot image. An operator can click on the work request to see any comments generated with the request. This particular request asks for a robot inspection. The operator can now log onto the request to perform necessary work. The CMMS changes the state of the robot to under maintenance to indicate that someone is performing work on the robot. The operator can now add a work template to the work request and perform work. Once the work has been done and the problem identified, the operator may add final comments and complete the work order. The RFT's web-based HMIs allow remote access and monitoring. Information displayed on the HMI includes streamed video, component status, current process, and sub-HMIs for RFID, part ordering, and diagnostic signals.